So today we're going to be talking about simplifying radicals. Now, when you think about the word radicals, while you might get the sense that it's one of those totally tubular Teenage Mutant Ninja Turtle sort of terms, it really refers to this square root sign and the values underneath those square root signs. So for example, here we have 3 times the square root of 3, or you could also hear it as 3 root 3, or the square root of x plus 5. Now, you can simplify radicals by removing perfect square root factors. These two values right here do not have perfect square root factors, so they are in simplified form. But what we're going to be doing is taking a look at a couple of examples of values that are not in that perfect square root form. So for example, here I have the square root of 50. Now, when I want to simplify the square root of 50, I'm going to go ahead and create a factor tree like we've done before in the past, but this time, instead of just focusing on the prime factorization, I'm going to try and break it up so that I can find a perfect square factor, in this case 25. Now the idea there is that because I have 25, I can break that out into, now I can take the square root of 50 into the square root of 2 times the square root of 25. And I think you're going to see here where the magic happens, because the square root of 25 we know is the whole number value of 5. So now I can combine 5 times the square root of 2, and so that's going to be my simplified form of 5 times the square root of 2, or 5 root 2. You can also do the same thing with variables as well. You just have to think about the square root factors back to our unit on exponential notation. So in this case I'm going to start first with the square root of 45. Now in this case, it should be pretty easy to see that 5 times 9 gets me 45, and I want 9 because 9 is that perfect factor. So then I can take the square root of 5 times the square root of 9, and the square root of 9 is really what I'm interested in, because then that becomes 3. So now that part becomes 3 times the square root of 5. However, the challenge comes into dealing with this a to the 5th. How do I find the square root of a to the 5th? Well, I know some of you are already saying, Mr. Chavez, you can break this up into the square root of a to the 4th times the square root of a, and you're totally right, because the square root of a to the 4th is a to the 2nd, and then we're still left with the square root of a, which has no perfect square factor. So now I'm going to take this value here and combine it with this value here. So you can see that my final answer then is going to be 3 from here, a squared from here, right? These are outside of the radical sign, and then I have times the square root of 5a. So you can see I've separated the values that were outside of the radical symbols and combined the values that were inside the radical symbols to get my final answer here. So my simplified answer of 4a to the 5th is 3a squared times the square root of 5a. Now you can also multiply radicals as well by combining everything underneath the square root sign. So in this case I have the square root of 8 times the square root of 12. So the first thing I'm going to do is go ahead and combine those values. So now I have 8 times 12 underneath the square root value, and that gets me the square root of 96. Unfortunately, 96 does not have a whole number square root value, but I can factor 96 to find a perfect square factor of 16 and 6. So even though I could have divided 96 by 2, I want to think about perfect factors that would fit into 96. And so I get 16 and 6. So in this case, then, we're going to move back over here, and now instead of 8 times 12, I have the square root of 16 times 6, which means I have the square root of 16 times the square root of 6, and we know that the square root of 16 is 4, and the square root of 6 really doesn't have a whole number factor there. So my answer to the square root of 8 times the square root of 12 is 4 root 6. So now what I'm going to do is I'm going to go ahead and give you a challenge problem here. You have 5 root 3c times 6c. Think about the steps we've been doing and keep an eye out for the c's, as they will provide some sort of answer as well.